Okay, so we'll get started now. Yeah, so like I just said, if you just showed up, I'll be recording this. So if you know of someone who isn't here, let them know, and I'll go through and check and see if someone didn't make it and make sure they know that they can watch this on YouTube. So yeah, so my son is in daycare for the first time, and I don't know if I mentioned this, but he'll probably get sick a lot, and he did get sick, and now I'm sick. So I haven't been cleared to come to campus. I don't think it's anything serious, but just to be safe and to follow protocol. This may happen a few more times throughout the semester since yeah, he hasn't been in daycare in like a year, so he doesn't have the immune system built up. So I'll email as soon as I can. I hope it won't be 9:30 the night before an 8 a.m. class. But thanks for bearing with me on this. And as far as Friday, so if you have lab today, I also emailed you, we'll be meeting via Zoom. And Friday, just I'm waiting to hear back about kind of the next steps. If I need to, I assume I need to get tested for COVID and then wait for the results. So I'm not sure how long that'll take. So I'll email you guys either way about Friday if we're meeting in person or on Zoom again. Any questions about that? All right. So I was going to touch base a little bit about the outline. So I looked through everyone's outlines. I think they looked really good. I graded all of the ones that were turned in. And I think everyone got 2 out of 2 points. So you guys are on the right track. And I think as you do more outlines, you'll find what's more useful to you. But I think what everyone did is a really good baseline for sort of how to outline the chapters. And I think there were a couple where I said, a little more detail might be helpful. So let me know if you have any questions about those, but everyone did a great job. And let's see, I don't know when the next one is due. I don't have that up in front of me, but let's see. Not until the 1st of February. So the 1st of February, you'll actually have your chapter 2 outline due, and don't forget about the disease selection for your group project, your group video project. I have a couple of those turned in already. So if you haven't kind of looked into some of those diseases, take some time to look into those and rank them and upload that spreadsheet. So that's due February 1st, as well as your chapter 2 outline. And I'll remind you guys of that. Well, that's coming up really soon. So I'll remind you guys of that again on Friday. All right, any questions about that? Okay, so we're a little bit behind. That's okay. I'll get caught up eventually. So I'm gonna, let's see, share the screen. We're gonna continue on with some of this mapping of the human body. And I think I ended here with you guys. So the cavities, I may have gone through them sort of quickly, so I want to run through them again. These are just, and if you had lab, we also went over them in lab. So if you have lab today, you'll see this again today. The cranial cavity basically houses the brain, and then the spinal cavity houses the spinal cord. That's pretty straightforward. Those two are really easy. The pleural cavity, like I said, pleural refers to anything dealing with the lungs and respiration. So the pleural cavities here are going to house the lungs. So there are 2 cavities, which you can see from the front right there. The pericardial cavity houses the heart, and the mediastinum is a little bit confusing. There's the mediastinum is sort of this whole cavity. Don't worry too much about it. The superior mediastinum is right above the heart, so that houses sort of the trachea and the esophagus, among a few other things. Pericardial, peri means around, cardial means heart, so the cavity around the heart. All of those red pieces make up the overall thoracic cavity. And then we have down here the abdominopelvic cavity, which we can divide into the abdominal and then the pelvic below it. So those hold a lot of organs, a lot of kind of complicated large organs that sort of wind a lot of times their way throughout different parts of the abdominopelvic cavity. And for that reason, we have this division of the abdomen into either 4 quadrants, so just a simple division into two upper quadrants, right and left, and 2 lower quadrants, right and left. Do note, and I mentioned this in lab as well, right is the patient's right. So it's going to be opposite of your right. So we're talking about the abdomen of the person whose abdomen it is. It's their right upper quadrant or their left upper quadrant. So keep the right and left is easy to confuse in that way. On the left here, we have these regions. So we've divided it, people who study the human body in detail have divided the abdomen area into specifically 9 different regions. So these are a little bit difficult to remember. I'll try to give you a little bit of information about what these terms, where the terms come from. So the roots of the words. So we still have right and left on both sides. So we'll start with that. So we have 3 on the right, 3 on the left, and then 3 down the middle. So we'll start on the right here. This is the right hypochondriac. Hypo means below, chondriac refers to the rib cage. So this is the right side of the body, kind of just on top of, or I guess sort of below where the rib cage would start. So the ribs are all, up here and they reach down into this area. So right hypochondriac, left hypochondriac. And then we already talked about the lumbar region on the back. So this is just the lumbar, these two, the right and left lumbar regions, sometimes they're called right and left lateral as well, are where you would expect to find the lumbar region on the back, but on the front. And then iliac. So iliac is synonymous with inguinal. So if you remember that term, when we did mapping of the human body, the inguinal region is the groin region. So the right and left iliac region of the abdomen, those are, you can call them right and left inguinal as well. So on either side of the pubic region. All right. And then in the middle, the very middle one is pretty easy. It's a term you're already familiar with, the umbilical. So umbilical region is around the belly button. Above that is the epigastric, below it is the hypogastric. So I already said hypo means below. Hypogastric refers to below the stomach. So gastric refers to generally the stomach. Epigastric, epi means on top of. So epigastric is the region on top of the stomach. So those 3 are actually, if you think about it from the perspective of what the terms mean, are sort of straightforward. All right, so that's the abdominal region. Like I said, we divide it into those, we focus on the abdominal region and divide it into those, well, basically down to 9 regions because there are so many different organs in there and it's important to sort of be a little bit more precise in the abdominal region. I think that's all I wanted to say about that. For lab, you're looking at, what organs are within each of these regions and within each of these abdominal quadrants. For lecture, don't worry about that. We don't really have time to go into it in both lecture and lab. So you just need to know the names for lecture and be able to identify them on a diagram. Okay, and these directional terms, again, if you've had lab, this will be stuff you've heard already. If not, you'll hear it again this afternoon. So don't worry if you don't pick up on it right away. So as I mentioned, a lot of this first chapter is just terminology. So we're trying to describe how we describe different parts of the body. We've gone through the map of the overall body, the abdomen, and now these terms are specifically referential terms. So that just means where one part of the body is in reference to another part of the body. So here you're going to be comparing 2 parts of the body. So if we start with superior and inferior, so I'll talk about the opposite in each pair. And this is set up really nicely, I think in your textbook as well as in the lab manual. So the superior direction is going to be anything up or towards the head, and inferior is anything down, below, towards the feet. Cranial and caudal, I don't really use. You can learn those terms, but I won't ever use them in here. So you can learn them or not learn them. That's kind of up to you. I always use superior and inferior. I think they make a little bit more logical sense. Okay. So superior, inferior. An example would be, let's see, your head is superior to your belly button. So your head is above your belly button. And then your mouth would be inferior to your nose. Your mouth is below your nose. So that's the kind of terms I'm talking about here. We'll do medial and lateral next. So you can see that down here. Lateral means, so if we imagine a midline drawn down the middle of the body, lateral is anything that's further away from that midline. Medial is anything that's closer in to the midline. So if we go back to the head, the ear would be lateral to the nose. So the nose is right along that midline. So pretty much anything is lateral to the nose. So the nose would be medial to the ear. So again, it's always in reference to another part of the body. You're always talking about two parts of the body here. And stop me if you're confused, please ask questions. Need to pop open the chat box here. If you have a question and you want to put it in the chat box, I have that open now. Okay, so lateral and medial. And then a couple more, we have proximal and distal. This gives students some trouble sometimes. Make a note that proximal and distal really is only used on the limbs. So you only use this on the arms or the legs. It's not the only one you use on the arms or legs, but if you hear proximal distal, you know you're talking about the arms or the legs. So something that's proximal, a body part that's proximal, is closer to the trunk. So here you can see the arrow moving towards the trunk. Distal is anything that is farther away from the trunk. And so if we think of the elbow and the wrist, the elbow would be proximal to the wrist. So it's closer in to the trunk of the body. The wrist is distal to the elbow. So the wrist is a lot further out from the attachment point to the trunk of the body. So proximal, distal. And then anterior and posterior, or ventral and dorsal. So these terms are interchangeable. Anterior is the same as ventral, posterior is the same as dorsal. I kind of use both. I think I use anterior, posterior more because it makes a little bit more sense to me. But anterior is towards the front of the body, posterior is towards the back of the body. The ventral dorsal comes from sort of more animal terminology. So we're upright beings. We stand on 2 feet. Ventral typically means like the underside, the belly side. So if you imagine a dog, its ventral side it's the underneath of it. Which if it was on its 2 rear legs, on its rear feet, that would be the anterior side. Dorsal is the back of an animal or us. So if you think of like a dorsal fin on a shark or a fish or a dolphin, that's on their back, right? So that's where ventral and dorsal come from. Do know both of those because I don't mean to, but I kind of use those anterior and ventral and then posterior and dorsal interchangeably. Okay, any questions about those directional terms? So these will come back up when we're talking about different body systems in the body. And I don't have, well, yeah, I won't go into that. Moving on. I don't want to confuse people. Okay. So no questions about directional terms? Good to go? All right. Oh yeah, and here, so I put a table on here for you guys so you have actual word definitions and examples. I thought that would be helpful. So you can look at those. I'm not going to go over each of them. Oh yeah, so superficial and deep. Those are the two that weren't on that diagram. We go over those in lab. We went over them in lab. I just want to touch on them. Superficial just means closer to the surface of the body. Deep means parts of the body that are deeper within a cavity. So here you can see the liver is deep to the skin. So that just means the liver is deeper within the body than our skin is. Our skin is the superficial layer. So superficial and deep, we won't use those a ton. Some with the muscles, but not a lot. Okay, so there's kind of word versions of that diagram for you, if that's helpful. And then planes. So planes of the body are important when it comes to medical imaging, and we're not really going to go into medical imaging. I know as part of the chapter, and I saw a lot of you guys put that in your outline. And I will say, you guys will have stuff in your outlines that I won't necessarily cover in lecture, and that's totally fine. I don't expect you to predict what I'm going to cover in lecture. But I don't have time to go through every single detail in the book. So it's sort of, an opportunity for you to get a little bit of information that I don't really have time to cover in lecture. The information that's in my lectures will be what's on the exams. So anything like the medical imaging, we don't really go into. I'm not going to ask you questions about that on the exam. So all of my slides are kind of your guide to what's on the exam, even if there's more information in the book than what I go over. All right. So yeah, back to the planes. So you can imagine slicing a human body. It's a little bit dark, but slicing a human body in multiple different sort of directions to get different views of the internal components of the human body. So that's the idea behind these planes. The transverse is sort of the easiest to understand. Transverse or horizontal section is just as if you sliced an organ or a body parallel to the ground, so straight across, right through, say, the torso. A sagittal, so I'm going to go over sagittal and mid-sagittal. Sagittal is anything that is perpendicular to the ground, so a vertical slice through the body. If it's not right down the middle, it's sagittal. If it is right down the middle, we call it mid-sagittal or median. Sometimes you'll see that term in lab. So mid-sagittal is a vertical slice right down the middle of the body. Mid-sagittal, vertical slice down the middle of the body. Sagittal is a slice down the middle of the body, but maybe not right down the middle of the organ that you're talking about, or if it's an entire body. This is usually in reference to very specific parts of the body that are being imaged, like by an X-ray or something, or an MRI. And then finally, we have the coronal or frontal section. So that is another vertical cut down the body, but rather than it being sort of down the midline, so you have a right and left side result, it's down the middle, so you have a front and back, an anterior and posterior side result. So that's coronal or frontal. So just know those terms. If I give you an image of a body with a plane through it, be able to tell me what kind of plane that is. Oops. Yeah, so here's some examples. I'm not going to spend too much time on this, but here we have a sagittal section of the head. So this is cut down, maybe not the midline, but cut down vertically through the head. So you can see the side basically of the brain and then see the spinal cord going down into the neck. So that's what you see with the sagittal. And then this is a transverse section through the abdomen. So this would be sort of this transverse or horizontal plane that's shown here, just a slice parallel to the ground. So you can see, I guess, sort of the tops of all of the organs. So here you have the liver, then the stomach, large intestine, spleen, etc. So you see that sort of cross section. And then a frontal section through the right hip. So this is going to be slicing the body down the middle, so you have a front and back. So that's a good way to see the hip bone and the femur here coming into and meeting up with the hip bone. Okay, so that's the purpose behind those planes. Otherwise, like, why do we learn these different planes for a body? That is why. Okay, and then this is just a quick slide. I think most people actually had this in their outline, which was nice to see. Just the importance of precision. So I've talked about a lot of different terms. They have some strange spellings and they're terms you maybe haven't heard before, but I wanted to point out that it's really important to be precise in how you use and spell these terms. So I'll typically give you a word bank. I know spelling can be really difficult, but you'll usually get some kind of word bank. So spelling won't be too much of an issue, but I do want to point out that sometimes one or two letters can create a whole different word, which can cause some major problems when you're talking about somebody's body or their health. So yeah, many terms are spelled pretty similarly, but can have really different meanings. In the health profession, detail is paramount. You want to focus on, if you're a detail-oriented person, you're going into sort of the right area. It is extremely detailed and probably more so than a lot of people want it to be, except I'm sure the patients want it to be extremely detailed and precise. I put a link here to a story. You guys can read that on your own if you want. I'm not going to ask you about it, but it's just it's a really sad story actually about a little girl who ended up dying because someone miscalculated some medicine for her just by a simple omission of a letter, basically. So that's why precision can be so important. So I'll let you read that if you want to on your own time. I think this wraps it up. Yeah, so I put review slides here in the interest of time since we're a little bit behind. I like going through kind of what we did, but you can see here, and hopefully you remember, since we've only had one chapter so far, what we've done. So look back at that if you want to. We talked about homeostasis and cavities, and then the mapping of the human body. And I did say, commit these terms to memory as soon as possible. So the more you work with them now, it'll pay off in the long run because they'll come back up as we get into these different systems. Not so much with the chemistry and the cells as we go through that. It'll be a little bit further down the road, but it'll make those chapters a lot easier if you already have those terms in your memory. Okay. Yay. Okay, so that's the first chapter of the book. As I'm opening the next chapter, feel free to ask any questions you have about that first chapter or just the class in general, assignments, etc. Oops. Nothing? Okay. I apologize, guys. I know this isn't ideal. Learning on Zoom is not an ideal way to learn, but we'll do our best and hopefully we'll be back in person on Friday. But like I said, I'll email you either way and let you know. Okay. Let's move into some chemistry. So this is a kind of major shift from pretty direct anatomy to maybe something that doesn't seem as important. But as I mentioned, if you break us down, we're all just a bunch of atoms. So we're going to start sort of at the base. And a lot of this hopefully will be, I'm trying to get there we go, the chat to pop up again in case you guys have questions. A lot of this will be review from if you've had general bio or if you've had, I think you had to either have bio or chemistry to as a prereq for this class. So hopefully a lot of this is review. So kind of, if you didn't understand it the first time, hopefully hearing it this time will make a little bit more sense. And goodness, I don't have enough space on my desktop. Yeah, if it didn't make sense the first time, hopefully it makes sense now. If it already made sense and you get it, then just kind of let it wash over you again and pick up on any little nuances that maybe you didn't pick up on the first time. All right. Okay, so the second chapter is the chemistry of life. So we're focusing on chemistry from a biological standpoint. We don't care all about the chemistry that doesn't really have anything to do with, and in particular humans, but living beings in general. So we're focusing really on just chemistry that has to do with us as humans. Yeah, so like I said, why are we talking about chemistry? I think I already made my case there. It's basically everywhere in all biological fields. Without chemistry, life basically wouldn't exist. All of the elements that we're made of, those are all atoms interacting with each other, which, yeah, going back to that hierarchy of organization, those atoms are interacting to make molecules, which are making cells, which are making blah, 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 further and further up that hierarchy, tissues and organ systems. So we have to know and understand that basic chemistry. And from a medical perspective, chemistry is obviously very important medicinally, as well as just understanding the functions of the human body, the physiology of the human body. We have a lot of different chemicals and molecules making their way around our body cavities, our blood vessels, our organs, etc. So understanding those levels is really important. Okay, so hopefully you agree that chemistry is important. Whether you like it or not is another question. I'm going to try to, like I said, break it down to sort of the simplest what you need to know for A&P type of chemistry. Okay, so first we're going to go over some sort of basic definitions: atoms, ions, molecules, and elements. That's not listed in the section title, but an element is just the simplest form of matter. It can't be created or broken down by normal chemical means. So if you look at the periodic table, which I'll show you in a minute, those are all of the elements. We won't really talk too much about the elements on their own. We're going to talk about how atoms of the elements interact with each other. There's 24 elements that have a biological role. So I actually don't know how many elements there are in the periodic table. I can't remember off the top of my head, but more than 24. But for our purposes, it's nice and simple. There's only 24 that have a biological role, and 6 of those really make up the vast majority of our body mass. So 99% of our body mass is made up of oxygen, carbon, hydrogen, nitrogen, calcium, and phosphorus. So if you aren't familiar with the chemical symbol for these elements, you want to get familiar with them and commit these 6 elements to memory, as they make up 99% of our body mass. So by and large, we're going to be focusing on carbon, hydrogen, and oxygen. So 3 of the 6 are in particular, when we get into the macromolecules, the biological molecules, we'll talk about carbon, hydrogen, and oxygen over and over again. But there's also nitrogen, calcium, and phosphorus. There are also some trace elements. These are required in very tiny amounts. So we have a very tiny amount of these trace elements in our body, but they're really important from a physiological perspective. Just because we don't have that many or that large of a volume of them doesn't mean they're not important. So trace elements, really small amounts, but really important in some physiological functions. And I think I'll talk about them, or at least like mention some of them on the next slide or 2 slides from now. And then there's what we call minerals. So minerals are elements, but they're kind of a specific kind of element. They're sort of a subcategory, like a specific set of elements are considered minerals. Minerals are anything that's extracted from the soil by plants. So we can't extract it. We have to eat plants to get these minerals. They make up about 4% of the body mass. So you'll see a couple that we've already talked about, calcium and phosphorus. So those 2 are considered minerals. The carbon, the hydrogen, the oxygen, those are not minerals. So minerals are specifically brought to us through eating plants, which is why it's a good idea to eat your vegetables, because you need these. And then there's chlorine. So Cl is chlorine, magnesium, potassium is K, seems a little weird, sodium, and sulfur. So those are the minerals you should be familiar with. And just know that they are inorganic, so they don't contain carbon. Anything that's considered organic contains carbon. They are really important in our structure, so physical structure, not so much a lot of our physiological functions, but the body structure, so our bones and our teeth. Obviously, we need calcium for bones and teeth. It's really important. And then also enzyme function. So somewhat on a physiological level, we'll talk about enzymes. They basically just allow chemical reactions to happen more quickly, but we'll get into that towards the end of this chapter. All right, so minerals, important in body structure. We have to get them basically through plants, directly or indirectly. Okay. Did this get cut off? No. Okay. So yeah, this is just a diagram showing essentially the important elements in our body. So we talked about oxygen, carbon, hydrogen, nitrogen, calcium, phosphorus. And then we have some of the minerals down here. And you can see, I can't see it because my chat box is in the way. You can see what percentage of our body mass they make up. And then down here, you can see the trace elements. So if you were like, what the heck are trace elements? They're listed down here. Ones you don't really hear a ton about. You probably know what copper is. Copper, fluorine, iodine, iron, obviously important in our blood, manganese, a lot of stuff vanadium, I don't know what that does, zinc, silicon. So there's all these really small amounts of these trace elements, but again, they're important physiologically. If we don't have them, we don't function correctly. Okay. All right, so now we're going to get into a little bit of information about how atoms of elements, so these are just like each element is made up, well, has atoms. So one atom of an element, we're going to talk about how one atom can interact with another atom from an electron standpoint. So I want to break it down to what an atom is, what they're made of. And again, I apologize if you know this already, but I want to make sure everyone's on an even playing field and on the same level here. So we have this this model of how atoms are structured. It's called the planetary model of atomic structure. You may have seen it. You probably at least looked at it in your chapter when you were making the outline. It was put forth by Niels Bohr. You don't have to worry about him, but it's called the Bohr planetary model of atomic structure. So we lay out an atom in a very sort of simplified way for us to understand it. So the center here, whichever we want to look at, is the nucleus. So the nucleus houses protons and neutrons. Protons are positively charged, neutrons are neutral. They don't have a charge. And then swirling around that nucleus, you have an electron cloud or energy levels, however you can call, or energy shells. They have a lot of different terms. So over here on the right, you can see, let me get this out of the way. You can see this kind of simplified version of what an atom looks like. So you have the center with protons and neutrons. We're basically going to ignore the nucleus for our purposes because it doesn't have, at least from our perspective, a whole lot to do with how atoms interact and bond with each other. So we're getting to how atoms bond. That's our goal for these next few slides, why they bond and how they bond. So we have the nucleus and then these energy levels or energy shells, or the outermost one is called the valence shell. So I listed that here. So the outermost one is really the important one that we want to focus on. That's called the valence shell. The electrons in the outermost energy shell are valence electrons. In reality, it's not this nice and simple circle around the nucleus. It's more of a crazy cloud with sort of like this, with electrons going in a lot of different directions. But for our purposes, we're going to keep it nice and simple. We just want to count essentially how many valence electrons there are. That'll tell us if an atom will bond with another atom based on how many electrons it has in this outer shell. Okay, so a couple of important points I don't think I wrote down here, so you're going to want to write this down. The first energy level of any atom can only hold 2 electrons. So you see only 2 here. That we're only going to look at the first energy level when we look at hydrogen. I don't think I have hydrogen on here. No, it'll be on the next slide. Hydrogen only has 1 electron in its first energy level. It's a really small, simple atom. So the first energy level can hold 2 electrons. So hydrogen, any atom, wants to fill up its outermost energy shell. It wants to fill its valence shell with as many electrons as it can fit. And the rule is for that first energy level, it can fit 2. So everything but hydrogen has 2 in the first energy level already. So hydrogen just needs 1 to fill its energy, its valence shell. Beyond that, the second or the third, really we're not going to go beyond 3 energy levels. The second energy level can hold 8, and then the third energy level can hold 8 electrons as well. So the goal of an atom is to fill its outermost energy shell, the valence shell. So here, carbon, you can see, has only 4 electrons in its valence shell. So it wants 4 more. So it's going to bond with 1 or more other atoms that can give it or share 4 electrons with it. So it has 8. It'll be happy if it has 8 in its outermost shell. Nitrogen has 5 electrons in its outermost shell. So it wants 3 more. So that's the main rule. And I think I have this on the next slide. I'm going to move on to that. Yeah. That's the rule for our purposes for chemical and atomic bonding, the octet rule. So atoms want to fill their valence shells, and they can do that in a number of different ways with different types of bonds. And we'll talk about those next. And this is called the octet rule. Octet refers to 8 because the vast majority of atoms have more than 1 energy level. So they need 8 in their outermost energy level. Here's little hydrogen. It only has that 1 energy level with 1 electron. So it only needs 1 more electron. So it can react with a lot of different things, which is why it's so important. And we'll see it over and over again, pretty much everywhere. Okay, so I already defined, valence electrons are the electrons in the outermost shell. And the number of those electrons determines if and how an atom will bond to another atom. So if we look at oxygen, these are kind of our 4 big elements that we'll be looking at over and over. So you want to memorize how many valence electrons each of these atoms has. Hydrogen has 1, super easy. I'll show you the periodic table and show you how to predict how many valence electrons they have on the next slide. How much time do we have? Okay, like 9 minutes. Okay, so oxygen here, really important, obviously, to us. So its first energy level is full. It has 2, so we're moving out to the second one. It has 6 valence electrons. So these 2 need to be paired up with something else. So oxygen is going to look for either 1 or 2 other atoms that it can basically share electrons with, so it fills that outermost energy level. Nitrogen, I already said, has 5, so it needs 3 more. Carbon has 4. I talked about carbon already too. 4 valence electrons, it needs 4 more. So it actually needs a lot of valence electrons to actually fill its outermost shell. But carbon is really, it bonds very well with a lot of other things. That's why it kind of creates the backbone of our biological macromolecules. So we'll talk about that. This setup kind of allows for it to really bond effectively with a lot of different elements. Okay, so take home message, atoms want to fill their valence shells. They'll be happy if they have 8, except for hydrogen. That's always the exception. It just needs 1 more. They'll be happy if they have 8 electrons in their outermost shell. If they don't, They're kind of searching for something to bond with so they can fill that outermost shell. That's kind of anthropomorphizing it, putting human characteristics on it, but it helps me think about it that way. So hopefully it helps you. Okay. All right. So here's the periodic table of elements. I assume everyone's at least kind of seen this. And it's organized in a very specific way. Chemists are very organized, and it actually falls out pretty nicely and helps us kind of predict the bondability, the different activity of these different elements. So what will bond with what other elements? All right, so I'm going to break down the main parts here. First, we're going to ignore that whole middle part. We're actually going to ignore most of the periodic table. Everything that's kind of down here towards the bottom, we're mostly ignoring. I don't think there's potassium and calcium. That might be the furthest down we go. So imagine kind of starting at the top, we're going to focus on these first two rows. And the first row is really just hydrogen. We're not really going to talk about helium. So these first couple of rows are where we're focusing a lot of our energy, particularly here you'll see carbon, nitrogen, oxygen. Those are going to be three really important elements. All right, so how do we tell how many valence electrons there are in each of these elements? Well, it's pretty nice. The first column, this is 1. It's a Roman numeral 1, not an I. So 1A, don't worry about the A. But that Roman numeral 1 means there is one valence electron in this, for every element in this column, it has one valence electron. For hydrogen, that means it's, you have to remember that hydrogen just has one electron to begin with, so it only needs one more. Down to lithium, it only has one valence electron, but that's in its second energy shell. So here we're into the second energy shell, basically. So again, hydrogen is kind of the exception to a lot of this stuff. So lithium, not going to talk about lithium. Well, we'll go down to sodium. We talk about sodium some. It only has one valence electron too. So if it has one valence electron in its second energy shell, it needs 7 more, right? So that's a lot. So sodium will react in a sort of different way, and we'll talk about that. But getting 7 electrons is a lot harder than just getting rid of 1 electron, right? So these elements can also just get rid of 1 or 2 electrons. That eliminates that outermost energy shell, and their next energy shell down is already full. So then they're happy. So that's another way that they can bond. All right, so first column has 1 valence electron. Over here, this Roman numeral is 7, VII. This column has 7 valence electrons. So it only needs 1, right? So it is really close to filling up its valence shell. And these atoms are extremely reactive because they only need 1 more. So they can basically react with a bunch of different stuff to just get 1 more electron. Oxygen has 6, so we already talked about that. There's the Roman numeral 6. It has 6 valence electrons. Nitrogen has 5, carbon has 4. So like I said, the periodic table is set up so you can kind of predict some different activity of the elements in it. And for our purposes, we're just focused on the valence electrons. So that brings us to chemical bonds. This is where atoms are basically interacting by bonding with each other based on their valence electrons. So this is what we've been moving towards. You're probably wondering, why do I care how many electrons are in the outermost shell of an atom? Because like I said, how many are there and how many that atom needs is going to determine what other atoms it will bond with. So if oxygen has 6 in its outermost energy level, it only needs 2. So if it can find another atom that will share 2 of its electrons with it, then those 2 atoms will bond together to form a molecule. There are 4 important types of chemical bonds. We're going to go over these on Friday, but I just wanted to introduce them here, just the names, and hopefully these look familiar. Covalent bonds, ionic bonds, hydrogen bonds, and van der Waals forces or interactions. Okay, so we'll get into that on Friday. Let me know if you have any questions about that chemistry stuff. I hope I explained it well enough to where you buy into the idea that the valence electrons actually do matter. Any questions before we leave here? I'll email you again, like I said, about Friday, whether we're meeting in person or online. Good? All right. Well, that is it. And I will see you guys in one form or another on Friday.